You know, when we talk about AI security, we usually picture this big wall, right? Defending against hackers from the outside. But what if the biggest risk isn't some shadowy attacker, but the power we accidentally give an AI on the inside? In this explainer, we're going to flip that whole conversation on its head. We're going to see that security isn't just a shield, it's how you actively design and define an AI's authority.
So here's our game plan. First, we're going to rethink where AI risk actually comes from. Then, we'll break down the three big pillars of control: how identity is really authority, how access controls are the guardrails for behavior, and how segmentation limits the blast radius when things go wrong. And to wrap it all up, we're going to get a little meta and define what this explainer right here is and is not authorized to do.
All right, let's jump right in with our first topic, rethinking AI security. Because to really get a handle on constraining AI, we have to start by tackling a huge assumption about where the real danger lies. So let me just ask you, when a security breach happens, what's the first thing you picture? I bet it's some super sophisticated, complex attack from some group you've never heard of. And yeah, those things happen. But the source material we're looking at suggests the real problem, well, it's usually a lot closer to home.
And there it is. The problem doesn't usually start with a bang from the outside. It starts with a weakness on the inside. It comes down to really basic stuff: not being sure who or what is taking an action, giving it way too much power, and not having strong enough walls between your systems. All of this creates what we can call invisible authority, the power for an AI to do things we never, ever intended. So how do we start to get a grip on this invisible authority? Well, it all begins with the first, most fundamental pillar: identity. As we're about to see, an AI's identity isn't just some username. It's its literal license to do anything in your system.
This is so crucial. Every single thing an AI does, every piece of data it pulls, every command it issues, every change it makes, it all happens under the umbrella of an identity. That identity is the gatekeeper. It defines the AI's entire universe, what it can see, what it can touch, and what it's allowed to change. Now, especially in regulated fields, an AI's identity can't be a casual thing. For you to have any real accountability, it has to meet these four non-negotiable criteria. It's got to be explicit, not just implied. It has to be unique, not shared with 10 other systems. It needs to be attributable to a specific purpose, and completely auditable, so you have a perfect paper trail of everything it's ever done. And this chart just lays it out perfectly. The right way versus the dangerously common shortcut. On the left, you've got the gold standard: AIs using their own dedicated identities with minimal power that are constantly watched. But on the right, that's the anti-pattern, letting an AI piggyback on a person's login credentials. That is an absolute recipe for disaster because you lose all ability to know who or what did something. Okay, so we've established who the AI is through its identity. Our next pillar is all about defining what it's allowed to do. Let's dig into how we can constrain an AI's behavior using access controls as critical gates and checkpoints. You know, it's easy to think of access control as just, can this program open that file? But for AI, it is so much bigger than that. It's about controlling the very prompts it's fed, who gets to tweak its configuration, which other systems it's allowed to kick off actions in, and even the high-level decisions it can make. Every single one of these is a doorway for that invisible authority to creep in. Now, take a look at this system diagram. You've got the IT systems on the left flowing into the OT, or operational technology systems, on the right. See those amber boxes there, the ones labeled approval gates? Those are not just suggestions. They are intentionally designed checkpoints where authority must be explicitly granted. If your access controls are weak, an AI could just waltz right past those gates, and that's exactly the kind of mess we're trying to prevent. This leads us perfectly to our third pillar of control: segmentation. If identity is the who and access is the what, then you can think of segmentation as the where. It's all about building walls to contain problems and limit just how far an AI can reach. So here's the bottom line. Sooner or later, something will fail. It's inevitable. An algorithm will spit out a weird result, a system will glitch. The whole point of segmentation is to make sure that when that failure happens, it stays put. It creates a limited blast radius, which makes the problem a local one and, most importantly, makes it recoverable. Let's look at that diagram again. You see that hard line running right down the middle, separating the IT world from the OT world? That is a critical segmentation boundary. An AI shouldn't just be able to cross that line whenever it feels like it. Any action that jumps from the information space of IT into the physical world of a factory or a lab
That has to be a deliberate, fully logged, and absolutely minimal event. No exceptions. And what's cool is how these principles adapt. In a factory, an AI's access has to be constrained by physical safety rules. But in a lab, the same logic applies, but now the constraints are all about things like data integrity and chain of custody. The context is different, but the core idea of designing authority through identity and access, it's exactly the same. And when you put this all together, you start to see that the most common security failures are really just violations of these simple principles. Giving an AI way too much power, using one identity for everything, forgetting to review permissions, and letting systems talk to each other without explicit approval. These are the things that show up time and time again in incident reports. Which brings us to what might be the single most important sentence in this entire explainer. When you are designing security for an AI system, you are not just building a fence. You are actively, deliberately designing and defining its authority to act inside your world. In fact, that idea that security design is authority design is so important that we're going to apply it to ourselves right now. For our last section, we're going to practice what we preach and clearly define the scope and authority of this explainer itself. So on the left, this is our job. We're here to explain the mechanics of identity, access, and segmentation to get you and your teams thinking about how to constrain AI. But look at the right side. This explainer does not tell you which security tool to buy, and it absolutely does not grant approval for any specific system to go live. We are drawing our own clear boundaries. Let's just end with this final thought. These controls, they aren't just technical busywork for the IT folks. They are the fundamental language an organization uses to set its rules, to define who and what gets permission to act on its behalf. Getting this right is everything if you want to use AI safely. So I'm going to leave you with this one question to take back to your own work. When you really look at your AI systems, can you say with confidence that their authority was intentionally designed with clear boundaries? Or has it just sort of happened by accident, creating invisible risks you haven't even found yet?